Hello guys, in this video we are going to cover our lesson for stoichiometry. This will be the first video of a series of videos for this unit. Heads up, this series is actually going to be pretty long. Each video will probably be over 20 minutes. However, stoichiometry is one of those concepts that is extremely important for any person that is hoping to seek a degree in science. Not just chemistry, but I'm talking about physics, biology, anything in the medical field, engineering definitely. So stoichiometry is a set of skills pretty much that is going to help us really master the content. So what is stoichiometry? So it's composed of two words in Greek. The first is going to be stoichion, which is just another word for element, and metron, which is going to measure or the measurement of. So essentially what we are doing here is measuring elements. We're measuring the quantity of those elements that is present in a chemical reaction. So all of our calculations will have to do with the reactants and the products that are involved in that chemical reaction. So let's look at some mole examples. I will not go over that information again. We did have a video for that already. But I did want to give you guys an update, kind of like for you to see what a mole looks like in different examples. So we have lead, copper, sugar, water, mercury, sulfur, and table salt, sodium chloride. Just so you guys can have a visual. So when we say a mole, we're really not talking, for the most part, about huge amounts of quantity. Yes, it's a lot of atoms, it is a lot of particles and molecules, but in terms of like quantity, it really isn't that much. It's just composed of a lot of those atoms. So we are going to be looking at these three different relationships. We're going to take it one step at a time. In this video, we are going to focus mostly on the molecules and the particles for the atom in relation to Avogadro's number, which is 6.02 times 10 to the 23rd. So before we get started with that, we are just kind of go back. Something important is that when we say particles and when we talk about Avogadro's number, we're talking about a representation of those particles. And that could be in the form of atoms, molecules, formula units, electrons, and even ions. So it's a value that represents different types of particles. So don't be afraid whenever you see in a problem that is asking you for atoms instead of molecules or instead of particles. We can utilize all of these units for Avogadro's number. So before we get started with that, I want to introduce you to the idea of dimensional analysis. And it really is simple. It's based on relationships that are established. So I'm going to give you guys an example in terms of something that we are familiar with, which is time. So for example, if I wanted to know how many seconds there are in, 2 years. Actually, let's make it interesting, 12 years. We know that there is relationships between seconds and years. We know they both measure time, and we know that there are different units that are kind of like in between. We can talk about months and weeks and days and minutes and hours, and we know that there's established proportions between those two. So that's really what stoichiometry is about. Those relationships that help us get from one point to another, from our starting to our end. And we utilize a T-chart. So those T-charts, sometimes people call it a railroad track. Honestly, it's just a bunch of lines. It helps us really keep it organized. So this is not the only one way that you can solve it. There's many others. It's just I prefer dimensional analysis because that is the one we use in science. So our T-chart is going to look something like that. We are always going to start with what is given to us. So that's where it goes on the top left corner. So in our scenario here, we are starting with 12 years. And our end goal is seconds. So we're trying to get from years to seconds. And here I'm just trying to prove a point, guys. I'm not going to go into super detail with some of these units, but I'm trying to show you that there is a process that we follow. So think about this. We are starting with years, we're trying to get to seconds. That means that at some point, I must get rid of the unit year, because year is not the unit of time that I'm looking for. So the way we do it here in dimensional analysis is we divide it by itself. You might remember from algebra class that if you divide a unit by itself, essentially that's canceling it, because its answer would be 1. Anything multiplied or divided by 1 is still the same number. So we divide, meaning we cancel it. So now years is not what we're looking for, but what relationship can we think of that helps us get closer to seconds? And let's think about this. We got options. We could do weeks, we could do months, we can do days. Which one gets us closer to seconds? Hopefully you're thinking day, right? A day. And we know there's a relationship between years and days, but we'll get back to that in a moment. Now we are already cancel years, right? Now we have days. Days is still not seconds, but if I cancel day, I know that there is a relationship that helps me get closer to seconds. So from a day, we can go down to the hour. But hour is still not the unit that I'm looking for. I'm looking for seconds. So I can cancel hour, bring it down. And after hour, the next logical step would be minutes. Yes, you could jump all the way to seconds, but I'm trying to prove a point here, guys. We have minutes. Well, minutes is still not the unit we're looking for, but we do know that there's a relationship between minutes, right, and seconds. So from this point on, I would expect you guys to know that once you reach here at the top, the unit that you're looking for, that's how you know you are done, when those two units match. Then, now that we have all of our units here in place, we start filling it in with the relationships that we know. So we have days and years. What is our relationship? For every 1 year, we have 365 days. Yes, there's a few hours and a few minutes and a few seconds thrown in there that helps us have a leap year every 4 years, but we're not going to go into that just yet. Then we can have their next relationship, hours and days. We know that in every 1 day, there are 24 hours. The next relationship is hour and minutes. We know that in every 1 hour, there are 60 minutes. We also have that very last relationship that tells us that in 1 minute, there are 60 seconds. So this is dimensional analysis, this process that you have in front of you. You start with a unit, you end with a different unit. And everything in between is relationships between units that help us get from the starting to the end point. So the way you would calculate this information is multiply everything at the top, multiply everything at the bottom, and those two numbers, divide them by each other. So we would do 12 times 365 times 24 times 60 times 60, all of that divided by 1, because 1 times 1 times 1 gives us 1. So our answer comes out to be 378,432,000. So pretty large number that we have in seconds. So this is the same process we're going to follow. It's just that we're going to take it really slow and we're going to do relationship by relationship. And towards the end of the unit, we're going to put them all together. So let's go ahead and get started with some practice problems. Tells us here on the screen, how many calcium atoms are in 0.250 moles of calcium? Well, let's draw our T-chart. Let's write down what it's given to us. You always have to be given something to start with. And in this scenario, it was 0.250 moles of calcium. And our question is asking us for atoms. Now, this is one thing that every year my students never listen to. They always forget to write their units. Now, units, yes, they're important because they tell us what we're talking about and who we're talking about, like element-wise. But in dimensional analysis, they are extremely important. Without your units, you don't know what that relationship is. Here, if you weren't already so familiar with the concept of time and those relationships, Imagine if we wanted to do this problem without writing a single unit. You wouldn't really know which number goes where, right? If you don't know what that unit is. Because, for example, for all you know here, we could have done weeks instead of days. And that changes the pattern of everything else in your problem. What if we hadn't done weeks? We wanted to do, months. Well, first of all, not every month has the same amount of days, so that complicates things. So the point here that I'm trying to make is our units tell us what number goes where. So when it comes to stoichiometry, these units that we're going to be using, you're not very familiar with them as you are with days and minutes and seconds. So writing those units, it's extremely important, and not just a unit, but also the element that we are talking about in each of those relationships, because we will get to a point later in the different lesson where we would actually be changing the element. So if you don't keep track of which element you're talking about, your units and your values will be wrong. And essentially your question and your answers will be wrong. So make a habit of always writing your units. So moles of calcium. Why did I bring that down? Well, I'm trying to cancel it, right? That's what we were doing. We were bringing down our units every single time. Just bring it down, bring it down. So that's what we're doing here as well. On top is the unit that we're looking for. And our problem here is atoms of calcium. So that's what we're going to write. Now, what is the relationship between mole and atom? Well, if we go back here, we can see that atom is one of those units that we can use for Avogadro's number. And we know that Avogadro's number represents 1 mole. So here, we are going to write 1 mole for every 6.02 times 10 to the power of 23. When we do that, we are going to multiply in our calculator, 0.250 times 6.02 times 10 to the 23rd, which is Avogadro's number, and that would give us 1.505 times 10 to the power of 23. Technically, we should be abiding by significant figures, but that's a different lesson. Right now, we're just going to focus on having 3 decimal places. Don't round until the very, very end, okay? So this is our answer. We're done with this problem, 1 step. And again, we will get to multiple steps just like this one, but we're taking it slow. Let's look at another example. We are asked to calculate the moles of 3.75 times 10 to the 27 molecules of oxygen gas. So we draw our T-chart. We start with our value that is given to us, and that would be molecules of oxygen gas, O2. Oxygen is the diatomic, so it comes in twos. And we are being asked for the moles of oxygen. So we begin the process. And you'll notice that the process is the same every time. We bring down the units so that we can cancel. And on top, we write the units that we are looking for, which is moles of O2. So then we look at the relationship. Let's go back to that. And again, molecules is one of those units that we can use for Avogadro's number. So for every 1 mole, we have Avogadro's number, 6.02 times 10 to the 23rd. Before I do the calculation, I do want to say something else, something important my students never listen to, but you guys should. If you notice, from problem 1 to problem 2, moles switch spots. In problem 1, mole was at the bottom, but in problem number 2, mole is at the top. Please do not memorize where the units go, because depending on the problem, depending on the question and the units that you're given, the pattern will change. And right now we're doing 1 step, but we will get to 6 steps, 7 steps at some point for my pre-AP students. So if you try and memorize the pattern, you have a very large number of patterns to memorize. It is a lot easier to just learn the process. Write what it's given, write what you're looking for, begin the process of canceling until you get to your answer. So make sure that you write your units and that you learn the process. So let's go ahead and put this into the calculator. And when we do that, we would do 3.75 times 10 raised to the power of 27 times 1 divided by 6.02 times 10 to the power of 23. When we put that into the calculator, we get the following number, 6,229.236. We're going to stick with 3 decimal places. This right here is our final answer for this problem. Let's look at one more. We are being asked to calculate the number of particles in 13.28 moles of nitrogen. So, dimensional analysis, we are starting with 13.28 moles of nitrogen, also N2, it's a diatomic. And we are being asked to calculate for particles, also of nitrogen. So we begin the process. You bring down the units. We want to cancel. We are canceling because we are not being asked for moles. We're being asked for molecules, so the moles has to go. And then on top, we write the unit we are looking for. So we write particles. And again, this is a one-step problem. I promise it won't be this easy. So then we look at the relationships. For every 1 mole, we have 6.02 times 10 to the power of 23 particles. So on the calculator, we will put this in. We would multiply the top, divide by the bottom, and when we do that, we would end up with 7.995 times 10 to the power of 24. We are rounding to 3 decimal places, and we won't do that until the very end. So this is our last answer. In the next upcoming lessons, we are going to learn about the gram, and we will also learn about how to change the elements, because right now we're staying with the same element. And we will also later on learn about how to calculate for gases in terms of standard temperature and pressure. So we have quite a few more lessons coming. We're going to take it really slow, one step at a time, and in later units, we will kind of put them all together. So make sure that you are writing down your examples, you attempt them for yourselves, and you also compare to how we're putting this into the calculator. It is not necessary for you to have a physical Texas Instrument calculator. It does help a lot, but there are also some others online that we can find. And honestly, our cell phones, they all have apps, and we can use those as well. So I will see you guys in the next video so that we can cover grams.